Okay, now we can talk about complex conjugates. For complex conjugates, you just have to understand what this word means, a complex conjugate. The complex conjugate is just going to be, and I'll just start with an example up here. If I asked you what the complex conjugate was of, say, 2 minus 5i, and I said, hey, what's the complex conjugate of that? Well, the complex conjugate would just simply be 2 plus 5i. So you simply just change the sign. That's all you do. Another example, maybe I had a negative 1 plus 4i. All right, the complex conjugate of that would simply be negative 1 minus 4i. So all you're doing is just changing that middle sign. You're not changing the real number part, only the imaginary part. And something neat happens when you multiply a number and its complex conjugate. You're always going to get just a real number, and it's always going to be positive. So we'll work the first one out, and then we'll show you the shortcut for the second one. So to work the first one out, 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is a positive 12i. And 4i times negative 4i is negative 16i squared. Well, the middle terms cross out, a negative and a positive, so you're left with 9 minus 16i squared. Well, remember, that is really negative 1. So that's going to be 9 plus 16, which is 25. So that's a lot of steps when you really only have to do 2 steps. Because the middle terms cross out every time, you just multiply the 5 times the 5. Well, so when you multiply 5 times 5, you just get 25. Negative 2i times positive 2i is negative 4i squared. And there's a shortcut for this. You know how every time I was just replacing the I squared with negative 1? Well, you could just remember, and this works every time, whenever you have an I squared, cross it out and change the sign in front, and it always works. So 25 plus 4 is 29. So that's the answer for the second example. All right, dividing complex numbers. Dividing complex numbers, you have to multiply both the numerator and the denominator by the complex conjugate of the denominator. And this is because you cannot leave a number with an imaginary unit in the denominator. It's considered to be not simplified. So the only way to get it out of there is to multiply by the conjugate. So the setup for the problem is to simply, you write the problem, and then you multiply the numerator and the denominator by the conjugate of the denominator. Now remember, you only change the sign in front of the imaginary unit. And then you just distribute. So you do 3 times 1. That's going to give you 3. 3 times negative 5i, negative 15i. 2i times 1, positive 2i. And 2i times negative 5i is negative 10i squared. And remember, we're going to use the shortcut for this. So it's just going to be 1 times 1 and 5i times negative 5i. We'll also use the shortcut up here. Remember what I said about I squared? So you end up with 3. These are like terms. Negative 15i plus 2i is negative 13i. And 1 plus 25 is 26. And don't forget, you still had the, I forgot about that, you still have the plus 10 over here. Well, these are considered like terms. So you'll get 13 minus 13i all over 26. Now, if all 3 numbers are reducible by the same number, like you can find a number that goes into all of them, then you can reduce it yet one more time. And 13 goes into 13 and 13i and 26. So your final answer is 1 minus I over 13. That's a 1. So 1 minus I over 13. We are not going to do the absolute value of a complex number because that's not in our standards, so we're going to skip that. And yours says, on your handout, it says modulus of a complex number. You can just X that out. And the only thing I wanted to go back to was, remember the very beginning when we talked about solving this problem right here? if we were to work this problem out, and by the way, it can't be factored, so the only way to do this is either complete the square or quadratic formula. I say the quadratic formula. Watch what you'll end up getting. Here's the quadratic formula. So you would have x is equal to positive 4 plus or minus the square root of negative 4 squared minus 4 times 2 times 5 all over 2 times 2. So you get 4 plus or minus 16 minus 40. And now can you see how you're going to get a negative number here? So you're going to get 4 plus or minus the square root of negative 24 all over 4. 4 plus or minus the square root of negative 24 all over 4. So what happens is this is actually an imaginary number. So you break down the 24. And you have a pair of 2's. And 2 times 3 is 6. So this breaks down to 4 plus or minus 2 square root of 6 all over 4. So this, oh, forgot my I. Don't forget your I. Don't forget your I, because whenever there's a negative under the square root, it's going to come out as an I. So this does have a solution. It's just not a real solution. It's an imaginary solution. And we can take this one step further because 4, 2, and 4 are all divisible by 2. The best answer is this, 2 plus or minus I square root of 6 over 2. And the reason you can't divide this 6 by 2 is because it's under the square root. So that pretty much sums up all the complex number stuff. You guys are going to do a lot of practice on it. I have some cards that you guys are going to do in groups, and just make sure that everybody is remembering all the rules, and you just can refer back to your notes if you need help. Have a great day.